Okay, let's start. Thank you for coming. My name is Alexander Nemish. I'm gonna tell you some interesting stories about Scala Collections. I've been using Scala for quite some time, and throughout my experience, I've gathered some things that I hope at least one of you will be surprised at least once. Let's go. Start with sequences. So a lot of time I see in different code bases things code like this. So we have a sequence type, seq type. It's a very convenient type. It's very short. It's very easy to type. It's quite generic. You can receive quite different set of actual collections. So it's obvious that we can use it for list, and it's gonna return one. You can use it for vector, but it comes quite as a surprise first time you see that you can actually call it with a mutable collection like array. How many of you know that sequence is not an immutable sequence? So part of you at least surprised. So it's easy to check that in predef, Scala type sequence, seq described as an alias for Scala collection sequence, not a Scala collection immutable sequence, which is easy to check. Scala collection seq describes a super interface for both mutable and immutable collections. Other surprise is a size on a sequence. So if you're a library developer and you write a function that should work across multiple types of collections, you can use sequence and call a size, which is fine when you use it for list, but when you use it for a stream, which is an indefinite collection, the size diverges. This function will never return. So be careful when describing that high-level traits as part of your API. There is a helper function in collections called hasDefiniteSize, and for definite collections, well, you know, finite collections, it is going to return true and false otherwise. So be careful. Other thing is this one. Do you see this? Is it okay? The sequence seq 1, 2, 3. Who at least once wrote something like that? Okay, so what's the actual collection here? Who knows? List. Maybe vector. Who thinks it's vector? It's list. But that's quite interesting what actually happens here. Because I think all of you know that it's actually a syntactical sugar for calling apply on a sequence, a seq object, right? And this apply has a variable arguments parameter, right? And variable arguments parameter in Java, at least it's realized as an array of ints in this situation. In Scala, it's a sequence. It's a sequence of ints. So what actually happens is something like that. So compiler will generate and create an array of ints. It's going to be wrapped in so-called wrapped array, which is a sequence, which implements a sequence. Inside that wrapper, there is a if that checks for null. So it's going to be branching. So we're going to create an array. You're going to call a function. It's going to branch. Then it's going to create a wrapped array. Then it's going to call apply. What the hell does apply does? So let's see. Okay, apply is going to do another branch. It's not empty. Okay, so it's going to create new builder. What's new builder? It's going to add all elements and return a result. So we have multiple calls. What the hell is new builder? If you search, you'll find that new builder for sequence is actually immutable list buffer. And this mutable, I will not show the list buffer code, but is going to traverse elements from left to right, and it's going to construct a list from left to right, which is obviously not what you like to do. You would like to initialize the list from right to left. It's going to do it in a performant way, but it's going to mutate its state in list buffer. And then in a result function, it's going to return that constructed list. This one is more in terms of size of code, but it's one of the simplest way to construct a list. It won't create any arrays, it won't create any list buffers, it won't branch, it won't do anything not very smart. So just so you know, if you do something like that inside a tight loop, inside the performance critical sections, be aware that a lot of garbage is going to be generated, and at least 2 branches will be executed. And I'm not sure is the code going to be monomorphized, so it's going to do calls and not in line. Okay, let's go to set. Believe it or not, this code returns false. Any ideas why? It's an old white from Paul Phillips' presentations from years ago, but still it puzzles me every time. Yeah, so basically toSet function is declared as one that has null arguments, 0 arguments. So it's not supposed to be called with parentheses. So what actually happens, this toSet returns a set, and these parentheses applied on a set. So it's a syntactical sugar for an apply. But to what argument does it apply? So Scala compiler tries to insert unit arguments whenever possible to make things work. So it tries to insert a unit inside an apply. But how can we have it compiled? Because we have a set of ints, and we apply to a unit. Apply on a set does it contains, you know, right? Okay. So type inference works and finds a list upper bound class for both set of int and set of unit, because set is covariant on its type argument, and it finds one, and this is set of any. And we do not have unit inside our set, so it falls. So it can't find unit inside a set of 1 and 2. Yeah, it's quite a surprise. So it's not exactly like that, but what happens similar to, so we call it toSet, we have a set of 1 and 2, it kind of gets converted to a set of any, and we call apply, and compiler inserts this unit inside apply, and it cannot find it. Okay, let's go, Hashmaps. I'll be describing mostly a situation when we use Hashmap as a cache, which quite often happens. So imagine you're starting your application and you preload some data that's you're gonna search on later. It's quite often is the size of data you're gonna load into your cache is known beforehand, and I think none of you want to wait another seconds while your application is starting up and preloading caches. So it's quite often a good idea to pre-allocate or at least hint your hash map on the size of the data you want to load there. So it's usually you can set an initial size for a hash map. So you're going to create an array of buckets of proper size. Unfortunately, Scala mutable hash map do not have a constructor that takes initial size. So if you search Stack Overflow, you'll see something like that. So you either create a new trade when you override initial size, or you create your own collection where you can actually parameterize on initial size, which is okay, but you can do this. How many of you do not know how hash maps work? So everyone knows. I'll remember you anyway. So, so what usually happens is in hash map there is a array of so-called buckets where entries are inserted based on the hash code of the key, and the hash code of the key is mapped to one of these buckets. Interesting things happen when we have a collision, when multiple keys mapped to a same bucket. There are multiple ways to collision resolutions in hash maps. One is called closed addressing, when the entries form a linked list of elements which are colliding on this bucket. Okay, this is how Scala Immutable hash map is implemented, and this is how it's implemented in many collections. In Java hash map, it's quite the same. Okay. Other way is called open addressing, when we do not form a linked list of elements. We store all entries inside the same array of buckets, and in case of collisions, we use one of the probing algorithms to find a place for a colliding entry. In case of linear probing, we search for next available, and you just insert into a next slot. This implementation, I think, has its benefits, one of which is cache locality, because entries are a bit closer to each other, and you do not need to do additional traversals in memory, making data cache reloads every time. Okay. In case we have many collisions in hash map, the list grows, but that's usually not a problem, because the size of a collection grows as well, and after hitting certain threshold, array of buckets is going to grow. Usually it's twice the size, and the elements going to be redistributed between buckets. And in case of a normal hash code implementation, you'll get a kind of uniform redistribution of elements. And that's why our hash maps actually work and perform quite well. But what happens if our hash code is not very good? And default Java hash code is, well, decent, but not great. There are attacks that partially inverse hash code functions for Java strings, allowing to generate many inputs with the same hash code. What happens in that way, you'll see this every input gonna be in the same bucket, and this list gonna grow like mad. So the size of bucket list is going to be huge, but everything is going to be in the one bucket in the long list. So if you want to check whether some key exists and an attacker could generate such a map that there is a long list of elements, the complexity of looking up in such a hash table will be n squared. And that was the basis for denial of service attacks on many servers in, I think, early 2010s. And many platforms were addressing that in multiple different ways by choosing more secure hash functions like zip hash or other ways. For example, a Java 8 hash map changed its implementation so that after hitting certain threshold of length of this list, This list actually converts to a balanced binary tree, changing complexity from n squared to n log n, which is significantly better. And then it goes back after hitting another threshold. But Scala mutable hash map does not do this. So be aware, if you cache and store user inputs, string inputs, for example, or you have not a very good hash code implementation, be aware that this attack is possible on your services. Also, there is, I've never seen it's been used, and I think it's a surprise, we'll see. There is a AnyRef map collection. Who have ever used one? No one. There is an AnyRef map collection in Scala Collections. It's a mutable hash map that uses open addressing instead of linked lists, and it claims to be significantly faster for basic operations, and I believe so. Because if you take a look at its implementation, it contains array of hashes, array of keys, and array of values. Those are close to each other. Those are arrays. It's going to be good for cache locality. It's going to be fast. Also, this hash map has a constructor that takes initial size as an argument. So it's quite useful to for your caches. It's going to be fast. It's going to be pre-initialized with a proper array of buckets. Also, it's often the case when you load your data, you can manipulate it, delete the old one, whatever, prepare your cache for usage. Then you can actually call a repack function that's going to reconstruct a map with the proper sizes of buckets and clean state for maximum performance. Scala mutable hash map does not disclosure this kind of repack method, so AnyRef map has it. So it's quite useful collection to use. And there is also a specialized version of this AnyRef collection. It's called long map, and it's specialized for long keys, using array of long as keys field, which is going to be a Java array of long, which is, you know, just a bunch of bytes in memory in a straightforward manner. It's going to be fast. Also, just use it whenever your key is long. Also, there is a beautiful tree map, but with trie or whatever. Tree map. It's a concurrent concurrent map that's based on the work of by Phil Bagwell, which designed a bunch of very performant immutable collections. I believe that was him who described hash array mapped trees first time, and it was a basis for closure immutable collections. So Alexander Prokopets improved this design, and they came up with this beautiful collection that, using compare and swap operations, does a lock-free, constant time concurrent hash map implementation. It performs slightly worse than Java's concurrent hash map, but it allows a constant time lock-free creation of read-only snapshots. So you can get a snapshot of the current state of a hash map. You can traverse it. You can search in it while it's being updated in other threads. Java concurrent hash map does not allow this. So, to wrap it up, mutable hash map unsafe to use in case of not very good hash code implementation. Anyref and loan map are cool alternatives. You can initialize sizes of those collections when the size is known. Repack is available in these collections. And treemap is a good alternative concurrent hash map implementation with consistent iterators. I work for a company called IOHK. We're building one of the top biggest cryptocurrencies in the world. And we are hiring. So if you're interested in writing financial contracts on our smart contract system, join. That's it. Thank you. Sorry?
Where are you located?
It's worldwide. All positions are remote. Any questions? Cool. No questions. Were you surprised at least once? Yeah. My job is done. Thank you.